And welcome everybody to the Daily Space Weather. We're coming at you a little bit late today, so apologies for that. We've had a couple of M-class flares in the past 24 hours, and a dud when it comes to solar storm forecasting. Of course, we were kind of on it from day one, and NOAA actually came through with a quite accurate forecast. We'll be covering that and lots more today at the Smash News Network, least busted name in news. And thanks for tuning in and stargazing with us here. This is the past 24 hours in SDO 131 plus 171 angstroms. We'll show you some close-up imagery of that a little later in the video. First, let's look at the filament fest that's going on, because this is a huge story. Some well-defined coronal holes rotating in here, but also solar filaments. So you can see really clearly the ones that are hanging off the limbs, like this huge prominence up here. We call them prominences when they overlap the limb. And when you see dark absorption features like these up here, those are actually filaments, not prominences, until they rotate toward the edge of the solar disk. Then they'll become a prominence. I would also note there is a huge plasma bridge right here where we have the Earth scale located. We've got active regions on both sides. We've got a huge bridge of plasma extending well out of the frame there. So we are showing the extended corona, but it is certainly well outside the frame, so the likelihood of major flares is certainly highest around the western limb, in my opinion. So here are some close-ups of this filament fest. It is quite good. Coronal holes here in the southern hemisphere, a very well-defined South Pole-oriented coronal hole down here. This is a North Pole-oriented coronal hole over here, rotating off to the western limb of the solar disk. We have some plasma activity over here as well. You'll see some CME activity coming from this active region. Great imagery there of prominences. And don't forget the northeastern limb, the source of two M-class flares. So those are both decent-sized M-class flares showing up there, those two brightening events, right at the beginning and end of our 24-hour clip. Again, coming at you a little later today than usual. So here is the yesterday plus today imagery from SDO intensitygram. And what do we got? We've got some evolution of this sunspot over here. It looked like it was going to fizzle out, but then it started to grow again. So that's going to increase the probability of X-ray flares around the limb. We've got a massive series of sunspot groups here setting. As far as that, that's sort of the most interesting thing happening here at the moment. Besides that, most of these groups fairly stable. And let's take a look at the colorized magnetogram next. There's your colorized magnetogram here. No major changes in terms of new sunspots or sunspots evaporating or particularly growing in the past 24. So let's do a brief rundown here of what's going on Crescent Earth. Sakurajima is exploding. It's producing an 8,000-foot ash plume. This is our volcanic rundown, by the way. Suminosejima producing a 5,000-foot plume of volcanic ash. And the effusive eruption at the Kilauea Halema Uma'u lava lake has been decreasing for the past 24 hours. Popocatépetl exploding in central Mexico, producing a 21,000-foot plume of volcanic ash. That's flight level 210 from Popocatépetl. Central America features Fuego exploding, flight level 150. Headed down to South America, Sangay in Ecuador, producing a 21,000-foot plume of volcanic ash, flight level 210, flight level 150 over Revenador, and Sabancaya producing continuous emissions for Peru, likely fertilizing the area to the east of the Peruvian volcano Sabancaya. Next, looking at seismicity for the past 90 days. There's your 90-day bar graph. Let's look at the past 24 hours, which did feature a significant quake. It was a 6.3 right on the coast of Turkey near the Syrian border. So there is the location of that, south of the Gulf of Alexandretta. Try saying that one 3 times. Alexandretta. Anyway, that's the location of that. That one came through at 17:04 yesterday, Universal Time. And let's check the list here. We're going to just briefly scroll up. We'll cite quakes above a 5 magnitude. So Solomon Islands also had a 5.1. That was only about an hour after about 50 minutes after the 6.3 at Turkey. Solomon Islands, located there northeast of Australia. And if we miss anything, just let us know in the comments. Thanks everybody who's been leaving comments. Thanks to our new subscribers for the past couple of days. We appreciate your seeking out space weather facts. Next, South Sandwich Islands at a 5.0. 5.5 at Alaska there. South of the Alaskan Peninsula there. That was at 5:35 this morning. Also a 5.3 at Iran. Iceland also had a 5.1. And that brings us back to space. So hey, welcome back to space. You'll find zero alarmist propaganda on the channel, just citing facts. So this is our house favorite wavelength, and apparently it's a crowd favorite also. The 171 angstroms wavelength is indeed spectacular. It's great at showing the lower corona. It'll show you how plasma is aligning to magnetic fields in those areas. The corona, it's a chaotic place indeed. Let's show the full disk imagery of... Oh, let's not show the full disk imagery. All right. 10.7 centimeter radio flux currently at 160 solar flux units. And bear with me a minute here. I just want to make sure I didn't fail to show you anything. All right, we are good. 10.7 centimeter radio flux at 160 solar flux units. And there's the 1 year graph to put that in context for you. The 10.7 centimeter radio flux is represented by this black line. And it looks like we've reached another support point here at 160 solar flux units. I believe that was the same as yesterday. See yesterday's daily space weather video for more details on that. The red line down here is the sunspot number. And let's take a look at the Space Weather Enthusiast dashboard, because NOAA actually hit the forecast just right here. So 4.67 for the KP index at the moment is exactly correct. So although the rest of the forecasts were a little bit off, and you could certainly say the space weather community they might have been over forecasting a little bit. So, and of course we talked about it in the previous couple of days. We'll even refer you to some YouTube channels. We'll tell you some YouTube channels to watch and not watch later in the video. So yeah, that's what's going on there. The Space Weather Enthusiast dashboard, if you want to check it out yourself, it's part of the Space Weather Prediction Center. And it's got all kinds of links at the bottom there. You can see modeling of the Enlil spiral and so on. Down at the bottom here, you'll find all these links. Space Weather Enthusiast dashboard is right up there. And let's move on to some more data here. So the KP index, okay, they under forecasted by 0.34. So KP 4.33 is the current situation. That's a measurement of global geomagnetism for all you new viewers. And thanks for leaving a comment, Mr. Bordages. We hope you are landing every 900 that is attempted and that your collarbone is feeling better. Next, the past 4 hours of magnetohydrodynamic pressure. This is Earth's magnetic moment from space for the past 4 hours. And the largely positive BZ component of the incoming coronal mass ejection that's now sort of ramping down was what caused it to not be a stronger geomagnetic storm. Of course, it wasn't really a direct strike either. Anyway, that's the last 4 hours of Earth's magnetic moment from space, modeled in magnetohydrodynamic pressure. Next, Earth's magnetic moment from the ground, and we've got some great auroral imagery that we shared just this morning. If you don't follow us on Twitter, or if you don't have a Twitter account, make sure you get one, because we're trying to increase our followship in various online applications. So that's the last 4 hours of Earth's magnetic moment from the ground. That'll show you the most likely places for the aurora, pipeline, railway, and power line induction. So here is your real-time solar wind. And this is what caused this geomagnetic unrest period, which will subside the next time the KP index comes back because it's flipped back into positive. So we did have a pretty strong field here at 15 nanotesla and a very strong southward component there of negative 12 nanotesla. And that was enough to spark some geomagnetic unrest. And again, we did get some fantastic imagery. We got some red auroras actually showing up. I believe it was in Alaska. Again, see our Twitter feed all over the internet at Smashomash. Nice. Mike says his mom saw the aurora in Sudbury on Friday. Anyway, current conditions, at least the latest data we see here, are solar wind density of right around 5.5 protons per cubic centimeter. Solar wind speed here nominal at 401 kilometers per second. Again, the geomagnetic unrest will likely end at the next update of the planetary K index. Next, we'll look at the GOES magnetometers there, and you see those spiky readings. Those should smooth out in the next day or so, although there is a coronal hole high-speed stream close behind that coronal mass ejection. So we can expect to see that soon as well. Look for a big ramp up in the solar wind density, followed by a ramp down and an increase in the solar wind speed, which is what you see for a coronal hole high-speed stream, at least the initial high-density shock wave. Next, our top view ecliptic plane field plot. As you can see here, Earth is now in the South Pole oriented current sheet. North Pole current sheet rotating here out beyond stereo B. Stereo B having just crossed the sector boundary, as you can see right here. That's stereo B. Here's stereo A. So that's our top view ecliptic plane field plot. We'll also show the line of sight field plot. Here the sun's B field is depicted in blue. As we watch the solar cycle progress, and we've got some well-defined coronal holes, so let's do coronal holes before sunspots. So here's coronal holes. Again, we've got some well-defined South Pole-oriented coronal holes here rotating in. So all the ones that are on the eastern limb here are all South Pole-oriented. So this is south. This coronal hole down here, that's South Pole-oriented. This is South Pole-oriented. There you go, South Pole, South Pole. This one rotating out is North Pole oriented. So the B field is kind of going like this at the moment. As we are getting into the meaty part of the southern heliospheric magnetic field, the South Pole, we are entering the middle of the South magnetic pole, folks. So well-defined coronal holes here rotating in. Let's do an even closer look up here, since these are such cavernous coronal holes. Now, a little bit about coronal holes, folks. These are also solar radio jets. So these are emitting high-speed protons. They are coming out of there at hundreds of kilometers per second at least. And, these are like low-pressure systems on the sun. So, low-pressure systems on the Earth are associated with rain. Low-pressure systems on the sun are so extreme that they blast material, mainly hydrogen nuclei, but also helium nuclei, electrons, and other heavier elements out into space at high speeds. So that there's another low pressure. Again, that's blasting out high-speed protons, and it's also a radio jet. Of course, these are fixated at the poles around solar minimum, and at solar maximum, you'll see the equator populated by coronal holes. It's a super important aspect of the solar sunspot cycle. The solar polar field reversals are illustrated by the locations of these coronal holes. They show us the migration of the magnetic solar fields. So next we'll move to sunspots here, and there you go. Some great imagery there. Here are the sunspot views, and we've got this new group as we forecasted yesterday named 3234. All right, it was a little higher number than expected, but 3234. So that's our latest sunspot group right up there in the northeast. And it has been associated with some M-class flares, which we will get to here in just a moment. First, a good view of SDO continuum. So there's the past 24 hours. Again, most of these sunspot groups mostly stable. This group up here looked like it was going to evaporate, but it instead grew slightly. So with these setting groups in the west, we will see a reduction in the radio flux unless new sunspots grow, and a reduction in the sunspot number. So I wouldn't be surprised at all to see more sunspots popping up somewhere. We'll be keeping an eye on it. And when I say ion, well, pardon the nerdy physics pun. Next, looking at relativistic particles here, and the ghost proton flux is a flatlined. No spikes in that, despite significant flaring here. Even over the past 7 days, just about nothing showing up as a signal for relativistic particles. Here's our solar flare view. And those flares are actually, I think those are only C class. C 9.18 and C 9.05. So again, there were 2 M class flares here, just barely in the last 24 hours because we're coming at you so late today. We did have an M 3.34 and an M 4.77, which we will show you next. So here, right at the beginning and the end of this 24-hour span, we've got those 2 M-class flares. This is composite wavelengths here. This is 131 plus 94 angstroms. Both of those wavelengths take 10 images per minute instead of only 2, providing additional temporal resolution for observing solar flares. Now we're going to add 171 angstroms because it shows filaments. So this is 131 plus 171 angstroms. We've taken away 94 angstroms. There's the most major flare playing region in the past 24 hours. Let's also briefly go around the horn here because we want to show you the western limb and the transequatorial plasma bridge. First, the southeastern limb. A little bit of activity down there. And here's this plasma bridge. Once again, there's a bunch of material that is suspended by magnetic fields arching way up into the solar corona. As we have those 2 nearly symmetrical sunspots there on either side of the solar equator. Also keep in mind, folks, that this material here at the solar equator is moving very, very fast. And, the sun rotates faster than Mercury's orbit. So this material, I'm not sure the exact speed. Let us know in the comments if you are familiar with the exact speed of, like, this material, the equatorial rotation speed of the sun. It's not something I memorize. To quote Einstein, never memorize something you can look up. Now, if you enjoy the content and you'd like to see the videos continue to exist, remain publicly visible, and free for all to view, don't just press like and subscribe. Consider becoming a member of the Smash Team at smashomash.com/Smash Team. It's our own subscription services site. We didn't really just entirely replace Patreon. We are still on Patreon. And you can find a bunch of social media links there, Instagram, a permanent link to our Discord chat. If you want to send an instant message, do it on Discord. That's the Discord chat link right there. You need an invite to join a Discord chat. And we've included it permanently on the homepage and the Smash Team page. Make sure you log in and see posts. We do send out emails because a lot of people don't trust certain big tech organizations to send the notifications when we put up a video. So we manually send out email notifications on the Smash Team site. There's a gold, a silver, and a bronze level membership. There's even a gold annual paid-up subscription that includes complimentary merch, so consider that. Thanks to our Smash Team members. You may find a link to the Hemp Lucid shop there as well. Hemp Lucid, our latest affiliate/sponsor. We need additional sponsors. We're looking for a coffee sponsor. If you've got anybody in mind, or if you are a coffee sponsor, drop us a line. And that's sort of our next quest, is to figure out an organization who offers organic coffee. I don't care if it's whole bean or ground. But yeah, but there's Hemp Lucid. So make sure you check that out. Links below the video in the description, as well as at smashomash.com. So shout out to Hemp Lucid. There is also a link to the free mushroom gummies samples, which we will talk about a little later in the video. And today's featured product is Mensa, because I'm, of course, wearing it on my head right now. Mensa. It stands for Make Earth Not Suck Again. If you've noticed Earth been sucking for the past about 3 years, yeah, a lot of people are on the same page with you there. So it's up to you to push back against tyrannical nonsense and make Earth not suck again. Have you been listening to terrible decision-making by bureaucrats who can't even get out of their own way or do their own jobs, much less give you advice on certain types of very important life and death matters? Well, lots of people agree with you there, too. So make sure you Mensa and make Earth not suck again. Maybe tell your friends and foes about it. By the way, this does ship internationally, and we've actually sent some Mensa products all the way to Tasmania. Yeah, Tasmania. So yeah, it's up to you to make Earth not suck again. You need to push back and say, oh, is that a problem for you? Well, you're going to have to do something about it, because I'm not changing my behavior based on your terrible, terrible advice. I'm going to make Earth not suck again in my own personal way and life. So if you visit the link below the video, you'll find the Redbubble shop there. The products are in order of best selling if you follow that link. Thanks to everybody who's picked up product, and congratulations on surviving a global scamdemic so far. Next, let's take a look back. So I'm always interested in what's going on overhead. And you've got the sun, the barely crescent moon, the sliver of a moon there, and Venus, all overhead at the same time. Also, you could say the moon, Mercury, and you got a lot of stuff going on there. You've got Mercury, Saturn, the sun, moon, Venus, and Jupiter, all overhead at once here in Lehigh Valley, Pennsylvania, the location of the Smash News Network, least busted name in news. Next, looking at a solar system forecast, and thanks again for leaving comments, Robert and Mike. Just a moment here while I process these. I want to see if there's anything I have to answer in the video. I think we're good. But thanks again for leaving comments regardless. So here's our solar system forecast. We've got a barely new moon here, just a tiny sliver at the moment. Let's advance this 1 week. Earth is on a lonely side of the solar system right now. No planets over here at all as we speed away from Mars. There's where things will be in 1 week. No gas giants on this side of the solar system. Next, let's look at some coronagraphs, as we've got a coronal mass ejection erupting as we stream the video. So that's yesterday's imagery from George Mason University, 99 frames. We'll also show today's frames. And there's actually a CME coming out of the southeastern limb right now. It could actually have an Earth-directed component because of the data we see from stereo A. We've got some old data on the other coronagraphs. So these CMEs, I don't see anything with an earthly component here at the moment. But let's take a look at the view from stereo A and Soho-Lasco C3. So here's stereo A on the left, Soho-Lasco C3 on the right, which is unfortunately lacking the most current data. The latest we have here at the moment is 9:15. But if you look at stereo A, there is a rather diffuse plasma cloud coming out here. It's got a great empty space here in the middle of it. There's like a cavity there that's lacking plasma as that erupts. That could be somewhat on the earthly line. We'll have to wait until a little bit later in the day to see for sure on that. But there is it looks like two separate events, one slightly north of the equator and one quite a bit south of the equator there. Could have an earthly directed component. If so, it will be minor once again, as it's quite diffuse to begin with. So let's just let that play through here. We're going to bring this back a little bit. Keep in mind these are not synced. Pay attention to the time and date stamps at the bottom there, as those are two different spacecraft there. So stereo A about 10 degrees behind Earth, orbitally speaking, and then Soho-Lasco C3 directly in between Earth and Sun at Lagrangian point 1. We usually bring up 90 frames, by the way. This is on the Integrated Space Weather Analysis page. You can also look at the NASA Enlil spiral on that page if you like. Totally different than the NOAA Enlil spiral. So yeah, that's what's going on. There could be another minor earthly directed CME component here. If it's major, it's not going to be major, period. It's minor. So here's the past 24 hours. There's Soho-Lasco C3 in blue, C2 in red, and the the SDO 304 angstroms wavelength. And part of the reason we show that is because of limb darkening. So it always helps If you see a filament on the earthly side of the solar disk, you'll often see it darken the limb up in certain frequencies. 304 angstroms can show that. So we do have the full data here. Let's see. We should see a CME. Now, that could be an earthly directed CME here. Again, we'll have to wait a couple hours here. We'll probably put up some sort of an update, at least for the Smash team, about the propagation of that. Keep in mind our daily space weather videos come out once a day, hence the term daily. So anyway, that's the past 24 hours. And the reason that these stop and the SDO keeps moving is because of lacking data on the SOHO data feed there. So, but there is some plasma reorientation happening down here. That could be the CME, and it could be somewhat earthly directed. It could have a minor earthly directed component. It won't have a major one because it's not major in the first place. So let's look at filaments, as these things can go blasting off with basically zero warning. Keep in mind, you don't need to see sunspots or solar flares to see coronal mass ejections. And look at all these dark absorption features. Filament, filament, filament. Oh, that one's gone. But see ya. So that ejected, or it might have collapsed, but this filament here ejecting. You can actually see this one getting unstable and then blasting off. So that's the ground-based solar observatory at Cerro Tololo, Chile. Another very well-defined filament over here. And look at all the filaments around here. So this is certainly the area to watch, the western limb. And if you'd like to name filaments, you're invited to join us on Twitter. So just follow the hashtag #NameThatFilament. And just give Twitter a minute to catch up here, as we are a little bit too fast for the Junkware platform at the Smash News Network, least busted name in news. So let me just give it a moment here. There we go. And we'll copy that image, and then we'll hashtag #NameThatFilament and hashtag space weather. Name filaments after living humans. And one last thing about the Twitter feed, you can also find the free link, the link to the free mushroom gummies. And we found out about the shipping, by the way. People are getting charged shipping because the free shipping was only for the first 5,000 orders. So for that viewer who complained about the shipping, drop us a line, send us a message on Discord, or email us or whatever via smashomash.com's links. And we can actually get that shipping refunded for you. However, there is going to be shipping now because they quickly used up the 5,000 orders. So anyway, you can find the link there on the Twitter feed if you'd like to try out the Hemp Lucid mushroom gummy samples. So that's what's going on with that. Sorry about the confusion about that. They certainly promptly used up all of their free shipping options. So thanks to everybody who's picked up stuff. And hopefully you've been enjoying your stay in your bunker. Maybe you'll find the courage to emerge in a couple of days. So here's the past 24 hours in SDO 304 angstroms. A couple places to note would be this filament down here. I do believe it's going to erupt right at the end. Right? It looked like it was getting unstable. I'm pretty sure it did erupt. That could have an earthly directed component. You can also see another filament eruption right here. And great prominences there, and great high resolution for the SDO imagery. And that's the past 24 hours. Let's show the past about 2.5 hours from GOES 16 SUVI. So wider field of view here on the GOES 16 SUVI, and a little bit lower resolution than the SDO. Major filaments here. So huge capability for massive numbers of coronal mass ejections. It should be an exciting time for our channel to continue to correctly forecast things like coronal mass ejections. Next, going to our bonus features segment. We've got some significant charging hazards here of the surface charging variety. North of the equator here in the central, most of the Pacific Ocean there, just north of the equator. So significant surface charging hazards there caused by low energy electrons building up on the outside of satellites. So that's the Satellites Community Dashboard Satellite Charging Hazard Map. Here is your GOES electron flux. And seeing pretty low levels here, these should start to come back up off the floor. Let's check out the NOAA forecast model. NOAA pretty close there with the forecast. I would tend to agree with that green box, maybe a little bit higher than that, but nothing to really make a point of. Here's the one-year chart to put the relativistic electrons in context. They are measured at the F layer of the ionosphere using radiography. So let's take a look at that layer as well. As far as I know, we're the only channel in the world that shows the ionosphere. So here is the vibrational frequency of that bridge between Earth and space. Of course, the F layer of the ionosphere basically is space. I mean, you could make a valid argument that even the D layer of the ionosphere is indeed space. It depends on if you'd like to breathe or not, basically. Anyway, that's the vibrational frequency of the ionosphere, one slice of the atmosphere. And here is the anomalygram, showing anomaly in megahertz from the 30-day median. And of course, you may be noting this area right here. That is the South Atlantic anomaly. Now over the South American continent, once again, we documented its massive movement of thousands of miles. A few weeks ago, it has snapped back onto the South American continent. Is it an indication the magnetic excursion is ending? Or is it an indication that you should be very spooked that the Earth's magnetic poles are going to reverse? Let us know in the comments what you think, if you've been listening to alarmist nonsense or facts about space weather. Anyway, there's the latest ionogram, and there's the latest anomalygram. 14:15 Universal Time. Again, pardon the lateness of today's video. We figured better late than never, so here we are. Next, we're going to show the total electron content, and unfortunately, we don't have the global map here because there's something going on with the feed there. I don't know. Hopefully, nobody detonated nuclear weapons in space. Let's hope not, but in any case, this will show you the most likely places for GPS errors. This is the total electron content over North America. And again, please note the time and date stamps in the lower left. Things looking pretty normal here as far as the total electron content. Looks like some missing data might be in there as well. I don't know. Let's just show the anomaly here. There's the anomaly in the total electron content. Those areas, those orange areas, for example, those would be the most likely places to see significant GPS errors. Unfortunately, again, the global map not loading today for whatever reason. So we'll also show the latest solar intensity gram and latest solar magnetogram. Keep your eye on this area right here. Of course, this sunspot has produced some M-class flares already, so that's something to keep an eye on as well. Those two areas, the western limb and the northeastern limb, are the most likely places to see major solar flares. There's your magnetogram. And before we get to meteorology, take a moment to press like and subscribe. Thanks to our new subscribers. If you're new to the channel, leave us a comment. Tell us how you found the channel. Of course, the hashtag system seems to be broken on all major social media sites. And, you know, we insist that Google fix the YouTube junkware platform because it barely functions. In fact, if you want to hear about shadow bans, our channel's so shadow banned that we often have trouble finding our own videos. Yeah, for real. So it's berserk. And of course, there is no competition for our daily space weather content. We saw a niche because of a lack of the data that we wanted to see. So we started covering it. Check our playlist for additional content like product reviews and even things like recipes will show up in our playlists. There's more than space weather and meteorology. Now let's talk about the Oppenheimer Stench Project. Headed by Diamond, the blowhard from the Oppenheimer Stench Project, Diamond, a.k.a. David Moriello. And shout out to Smash staff because she noticed something very interesting. Now, Diamond's been on the channel and tried to shout me down, and failed at that, as he did with his solar forecasting and his grand solar minimum crap that he keeps spouting. Grand solar minimum, grand solar minimum, grand solar minimum. Sorry, dude, it's not going to become reality because you and your viewers keep chanting grand solar minimum. Anyway, Smash staff noted something very interesting, and this is what she noticed. If you click on channels, check this out. Okay, fine. Look at this. Grand solar minimum resources. He endorses suspicious observers. Look, there it is. Oppenheimer Stench Project endorses suspicious observers. Oh, man. Oh, that made my day. If you want to see somebody who really understands space weather, somebody who's a lot more qualified than I am to cover space weather, check out Tamitha Skov. I was just watching her live from yesterday, this morning, streamed only 11 hours ago, so check that out. If you'd like some space weather facts, her channel's chock full of them. Here she's talking about helioseismology, so check that out. Tamitha Skov, shout out to Tamitha. Trying to get her on the channel at some point soon. Keep in mind, if Tamitha does appear on the channel, it is not necessarily an endorsement. There are just some certain questions that we'd like to ask her about cosmology and so on, how heliophysics relates. Once again, thanks to our new viewers. If you are new to the channel, press like, subscribe, share, etc. Leave a comment. And if you haven't checked out our websites, if you're unable to open your cobweb-encrusted wallet because you're broke, for example, help us out by clicks. You can find the Redbubble shop, the Facebook page, Facebook group called Entropy Busters. Yeah, part of the reason that we have a channel is to bust entropy because, hey, disinformation is entropy. So, yeah, all right. So anyway, let's move on here to get to our meteorology segment, smashomash.com. And, oh, one last thing. Welcome to the Neo-Renaissance. Congratulations on realizing the channel exists. So we do still have some likely aurora happening here. As we transition from space weather to earth weather, let's take a look at the southern. The aurora australis. There's the most likely places to see aurora here at the moment. And there's the north. Again, things are ramping down here. We saw the BZ go into positive territory. That's the vertical component of the magnetic field. So it's unlikely to continue. This dud of a storm is ending. Next, let's look at global weather patterns here. So this is the point of this part of the video. Now, keep in mind, folks, also that we did previously compartmentalize these videos. So we put all our videos in separate areas. We put different portions, solar imagery, different solar data, the meteorology segments, all separate. And guess what that did on YouTube? That caused us to get less views. Yeah, less views. Think about that one. Is that berserk or what? What sense does that make? Here at the Smash News Network, we don't understand what sense that makes. It seems to be ridiculous. Anyway, these are the jet streams of the Eastern world. Shout out to our viewers from all around the planet. Incoherent jet stream here around Australia. It's like tripled up between northern Australia and the Southern Ocean. Here are the surface winds of this side of the planet. And there is a strong high pressure here south of Tasmania. You can see that counterclockwise rotation associated with a high pressure system for the southern hemisphere. Here are the surface winds of the western world. And here are the jet streams. Strong jet stream here over the eastern U.S. at the moment. Jet streams of the central world like Europe, the Middle East, and Africa are looking like this, and these are the surface winds, and let's blast through the rest of our meteorology segment here. We don't want the video to be too long. It looks like Madagascar is getting some extreme weather on its eastern coast. Next, we want to show you clouds and fog over the Americas. So we've got viewers from Brazil, at least one. Shout out to Bruce. Bruce Minas, I believe is how it's pronounced. And there are the clouds and fog depicted by the 3.9 nanometer radiation infrared satellite, part of the NASA GOES Interactive Weather Satellite Suite. And let's show the weather.gov page. So blizzard warnings in these orange areas and huge snowfalls. The snowfalls have been updated to show even more snow than expected. Anyway, if your location is lit, click your location. Lots of weather warnings here at the moment, and let's show some forecasts. Actually, before we show forecasts, let's show snow. So this is the 7th winter in a row that's pushing record levels of snowfall in the northern hemisphere. So you may be frightened that the planet is too hot. You may be frightened that the planet is too snowy. I don't know who's frightening you today on YouTube, but here are the facts. The snow mass balance has moved back into the one standard deviation between the 1982 to 2012 average. Now that entire graph should be updated because it's 2023. So this graph is now over 10 years old as far as the standard deviation, and the past 6 winters will have moved this graph. However, we are back in the meaty part of the range. So I think the record snowfalls here might be finally ending as this is a little bit less extreme. Keep in mind that is snow mass balance. So that's the 3-dimensional snow, and it does not include mountains. If you just look at the snow extent, it's actually below 1 standard deviation. So as far as the 2-dimensional amount of area covered by snow, kind of low, meaning Earth's albedo is not going to be all that high. And the snow-water mass balance, the snow-water equivalent rather, is way above 1 standard deviation. So huge amounts of snow in the mountains. Expect another epic melt season. If you're into whitewater rafting, it should be a great spring for you. So here are your forecasts. This is temperature anomaly in degrees Celsius based on the 72-hour GFS model. Some very, very warm temperatures here continuing in the eastern part of the U.S. and some very, very cold temperatures intruding into Montana, Idaho, Wyoming, eastern Colorado, the Dakotas, Nebraska, and Kansas. We'll also show the 72-hour GFS pressure and precipitation forecast, and there's a hell of an ice storm coming. Check it out, folks. That is going to be one excessive ice storm. I suspect there might be people ice skating just on the grass because that looks like an accumulating ice storm of epic proportions. So be prepared for that. Don't be driving in freezing rain unless you got studded tires, which are typically illegal to drive when it's not raining and so on. And we've got a Finnish viewer. Thanks for leaving comments, Jackie2, and also Cookie Spacey. That's your pressure and precipitation forecast based on the GFS 72-hour model. Heavy, heavy snows there coming to the Rockies. So here's your accumulated snow depth change in inches forecast. And again, this has been upgraded since yesterday. So we showed this on yesterday's meteorology segment. Today, it's even more extreme snow, especially for South Dakota and Minnesota. Now it's like going above 2 feet in certain sections there. That's your 72-hour GFS accumulated positive snow depth change in inches forecast. Dag. Looks like we're even going to get some additional snow here in Pennsylvania. It's been a very lacking 5 years in the Boston to D.C. corridor. Practically no snow for that period. So we're just going to bring up windy.com here just to show you the difference between the European and the GFS model forecast. There's the new snow forecast for the GFS model. Here's the new snow forecast for the Euro model. Looks like it's a little higher resolution there, as typically is with the Euro model. Again, there's the difference, GFS, there's Euro, again GFS, and there's the Euro model. Let's move on and blast through the rest of this meteorology data. There is your lightning mapper, a little bit of lightning over Tennessee and Mississippi in the past about 12 hours. Here's a real-time lightning map, and we've got no terrestrial strikes in the U.S. Next time you hear lightning, check out lightningmaps.org. It could save your bacon, and we've got some Spanish lightning happening at the moment. Some active cells there around Salamanca. Not Hector or Tuco, Salamanca. There we go. Some lightning there around the Spain-Portugal border at the moment. Anyway, there's your whole world map. Keep in mind the whole world isn't covered. There are only sensors in parts of the planet. You can, if you want to look up that information, you can actually show the stations there if you like. For example, right there. There you can see where all the stations are. It'll show you lightning, at least at those locations. And let's move to the U.S. Doppler radar. Some precipitation there around Hawaii and Alaska. We'll focus on the lower 48 as we're wont to do on most of our videos. There's clouds and fog over the U.S. There is water vapor over the U.S. We've got a significant impulse here of dry air coming through Washington. And that's going to help to push this air to the south, and it's also going to sandwich this low here. So this is going to cause some basically bomb cyclone conditions there as this air butts up against this high pressure zone. This high pressure zone is going to provide the impulse, and that moisture is going to have nowhere to go but onto the ground. Anyway, hope that helps. Hope you're not believing nonsense on YouTube or consuming nonsense on YouTube. It leads to lots of weird comments in our comment section. Remember, folks, ignorance is the root of all knowledge, and there are no stupid questions. However, there are stupid people. Here's the rest of your recap, U.S. Doppler radar. Clouds and fog depicted by 3.9 nanometer infrared radiation. And there is water vapor. That should clarify things, we hope. And thanks for tuning in to the Daily Space Weather at the Smash News Network, Least Busted Name in News. There is absolutely no competition. So we'll see you next time. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. Don't forget to Mensa, and may that solar wind be at your back.